That's a petabyte worth of storage, and it is running right now at roughly 17 gigabytes per second. That is a Gen 5 class bandwidth that you would expect from an NVMe. This was a result of me absolutely going completely OCD mode on all of this storage. 5955WX Threadripper in a WRX80. It's got 512 gigabytes of 2400 speed DDR4. That is a great setup for, in particular, running something like TrueNAS or, in my case, Proxmox. One of these is basically running two IOM6 modules. Those are a SAS 2 part. Now, the theoretical max speed that you can push through a SAS 2 with two connections is going to be somewhere right around 4.8 to 4.4 gigabytes per second per Jbod. When you're setting up a huge storage array for performance like this, you really want to focus in on having good sequentials at a specific size that matches your workload. And for the astute observers among my audience, of which there are many, you're probably saying to yourself, oh, you're just testing your ZFS ARC. Well, I'm going to show you that I'm not, because I've dropped the primary and secondary caches, and I've also got a static size set of 16 gigabytes for my ARC Max. And we'll be able to witness that by checking the mem and watching the actual writes to disk as we run this next test. And you'll see that we're going to write a lot more than 16 gigabytes worth of data. And when you're looking at the speed that we're getting, registering at 16.8 to 17 gigabytes, that's actually 18 gigabytes per second. And nope, that is definitely just hitting the drives directly. You can see the memory usage right there is capped at about 7.44 gigs right now. And that's really pretty awesome, especially given that these hard drives are Exos, X14, X16, and X18. So not even the latest and greatest out there. Like I said, 10 terabyters and 14 terabyters is the 60/60 mix. And the ZFS array that I've got set up right now, while we will get way more into it when we do the ZFS video, and I'll talk about other options, right now I just wanted to show, hey, I got a petabyte worth of storage viable and possibly usable. However, the redundancy on it might not be quite what I would hope for, and certainly I think that there is a good argument to be made for alternate arrangements for your Z pools, and this one definitely, I don't think I'm going to keep it like this. Each one of these 9305s, that's 1, 2, 3 9305s, is a 16E, and this has the 8644 connector. Most of the LSI SAS HBAs that have 16E, many of them are going to have a 2-chip setup. So 2 ports will be on one chip, and the next 2 ports will be on the next chip. And on the 9305 in particular, those are not connected together. So you can incur a pretty big performance hit if you actually were to go to port 0 and 2 or 1 and 3 when you're connecting this. Instead, you need to do 0 and 1 together and have that go to one of your independent JBODs, but with 2 domains here. So domain A, domain B in this cabling setup. And then the next one goes up to the next one. And you would continue that. That gives you the most performance. And in the instance of going to the back of a IOM6, you would need to have a QSFP adapter on the side of that. And this is one of the things that I will say you're not going to get performance speed benefits by going with the IOM12 versus the IOM6 in a DS4246. But you will get actually cables that are possibly cheaper. These actually, the QSFP ones, were a little bit expensive, and they are limited to 2 meters. I could not find 3-meter ones. So if you have a large span of space that you need to connect them, you can easily get up to 5 meter in the 8644 to 8644 category. So each one of these is cabled into the active port. There's a lot of different ways that people have shown, and certainly NetApp's own documentation shows cabling this in a different fashion with in, daisy-chained out. Now that's a redundant failover cabling, which does actually work for multipath. However, that is not a performance-based multipath configuration. The way that this is cabled to both of the ends and with nothing out is going to give you right about 4.4 gigabytes per second per JBOD. That's pretty wicked fast. This was a DS22446. It has been changed out. I got a DS224C You actually need to open the power supplies in these or else you're gonna have rattly things going on. You get a upgraded Nodge 1501. Make sure it comes with the caddies so that you don't have to buy the caddies externally and possibly, maybe not, run into an interposer issue. Let's get this tossed up there. All right. So one of the things that you need to do before you put these power supplies into that Jbod is remove some dampers that are in here, which you can kind of hear them like this, but you'll really hear them whenever they start going, when air is blowing, and it is kind of annoying. And so that top will just come right off. You might want to clean in here. It looks like there's a bit of gunk that has been sucked up in there. That's pretty normal. So in here, you're going to see that you've got a little pad that's attached here. And I would leave that attached if you can, and just start on this side. These actually just are setting on some pegs. Don't touch any of this down there. So just pull it up and back, and then you can kind of tilt it out. These are some huge brushless fans, can really crank up there and move a lot of air. But with those dampers inside their air channels, super annoying also. Let's see if we can get this without having to take this middle piece off. Sometimes you might have to take that middle piece off. There we go. All right, so then you can literally just stick your fingers up inside these and manhandle it a bit. I've done this on 2 of these Jbods, and I have yet to break any of these tabs, and every time it feels absolutely like I should be breaking the tabs, so get out of there. And I'm sure in a data center these prevent something, but in your home lab, this is probably overkill. All right, and then you just put these back on the little posts that are down in here. They look pretty clean. They're gonna be coming out of data centers almost exclusively. And then kind of make sure that it goes inside there a little bit and down in there, good. And now I'm gonna clean out the top real quick and put this back on. Like so. There's some plastic on the sides, so make sure that that goes back inside there. Got to push it down and then forward. You might want to pick it up and square it up. Make sure that your holes actually look like they're lined up really nicely. This is looking great. So I'm going to go ahead and put the screws back in now. So now with the air dampers removed, when you take this, much less noise will come off of it when you shake it. And you should definitely shake these and also the IOM6s just to make sure there's not a screw that's fallen into there. For some reason, a lot of these IOM6s, IOM12s, and the power supplies have screws that just kind of somehow got in there. This is very quiet. I mean, if you think of how much is running here, this is really actually quite quiet inside here. And 18 gigabytes per second, truly some insane numbers that we are pushing on these spindles. So all of these drives are all geared towards 16 megabytes or larger, and that is actually quite a large size for the record size for ZFS. Everything underneath that is going to fall onto the SAS SSDs, which will be a massive, almost 20-some terabyte, huge array of metadata. So this setup is smoky. And right now, just the spindles being able to hit a whopping, insane 16 to 18 gigabytes a second is freaking sweet. So let me know what your fastest array of platter-based hard drives that you've ever set up personally yourself has been in the comments below. Huge shout out to our members. Thank you for all you do. And definitely I want to give everybody else a shout out that is on Buy Me a Coffee, Patreon, and all the other platforms out there. Really do appreciate what you do for the channel. Be sure to hit like, subscribe, and ring that bell so you get notified when more weird and possibly really cool content like this comes out. Part 5 in the works. Out soon. Everybody have a great rest of your day, and I will see you next time.